Welcome to today's video. Today we're going to be focusing on factoring quadratics. Now, the big thing we want to focus on today is for when a is equal to 1. We're going to do a couple different ones where a is greater than 1, but your goal tomorrow in class is specifically the ones where a is equal to. Hopefully you have the note sheet in front of you. If you don't, take out a fresh sheet of paper and we'll make sure to get you a fresh copy of the notes tomorrow. Now, when it comes to quadratic, the big thing is you're going to hear me say that a lot. A quadratic is when we have ax squared plus bx plus c. A, b, and c are all numbers. Now, b and c can be 0, but a cannot be. Otherwise, it's not a quadratic. Now we have a linear function. So, quadratics mean a is either equal to 1, greater than 1. Now, this is the opposite of FOIL. When we did factoring out the GCF, it was the opposite of distributive property. Well, now we're doing the opposite of FOIL. Step 1, we're still going to factor out that GCF, if we can. Not every problem's going to have it. Then we're going to identify A, B, and C. We're going to multiply A and C, and we're going to go from there. Now, if we look at our first problem, again, we want to remember quadratics is ax squared plus bx plus c. So in this case, a is equal to 1, b is equal to 9, and c is equal to 20. Now, we want to take a times c, and it's always going to be a times c. So this is 1 times 20, which is equal to 20. Now, we want to break it down into factors. So I have 20 and 1, 10 and 2, and 5 and 4. Here's what we want to look at. We want to know, based on our b, which one adds to get 9. Well, 5 plus 4 equals 9, where 10 plus 2 is equal to 12, and 20 plus 1 is equal to 21. So that means my factors for my a times c are going to be 5 and 4. Now, here's where that comes in. We're going to take my b term, since that's what we were searching for, and break it into 5x and 4x. Since they're both positive numbers, we're going to keep it that way. And I'm just going to bring down a and c as they are. So all we did was take these factors and split them apart. Well, now we're going to use factor by grouping. So I'm going to take my first two terms and my last two terms. Well, my GCF here is x, and I'm left with x plus 5, plus my GCF in my second set of parentheses is 4, and I'm still left with x plus 5. Now, since we have both the same things in our parentheses, that tells me I have x plus 5. My outside that I have left is x and plus 4. This is the quadratic factored form of x squared plus 9x plus 20. That is your final answer. And if you were to use either FOIL or the table, you're going to get x squared plus 9x plus 20. So when it says factor, you need it down to 2 binomials. If we look at example 2, again, we want to keep in mind quadratics, ax squared plus bx plus c. Well, a has a value of 2, b has a value of 5, and c has a value of 2. So that tells me when I do a times c, it's going to be 2 times 2, which is 4. So now I'm going to break it apart. I have 4 and 1, and I have 2 and 2. However, my b tells me that 4 plus 1 equals 5, and 2 plus 2 equals 4. So I want to use the 4 and the 1. Again, we multiply to get AC, but then we want to add to get B. Now I'm going to take that, and I'm going to break 5x into positive 4x plus 1x. And I'm still going to bring down A and C. From here, we're going to factor by grouping. Well, if I pull out my GCF, I can pull out a 2x, and I'm left with x plus 2. From the other side, well, if I look, they don't have anything in common, so I'm just going to pull out a 1. Well, 1 divided by 1 is 1x. 2 divided by 2. Well, if I look, I have the same things in parentheses. So if you don't have a number other than 1 that can be pulled out, still pull out that 1. It is still considered a factor. So now I'm left with x plus 2, because that's the same in both my parentheses, and I have 2x plus 1. I have two binomials being multiplied together, and if we were to use FOIL or the table, it would work. Now, if we look at this equation, the one thing we need to keep in mind is we need to factor out a GCF if we can. And the first two problems, we didn't have any. But in this problem, I can factor out a 3. So I'm going to, and I'm going to be left with a squared plus 10a plus 21. Well, now I'm going to pull my a, b, and c from that factored equation. So I have a is equal to 1, b is 10, and c is 21. Well, that tells me a times c is 1 times 21, which is 21. If I draw out my factors, I have 21 and 1, and I have 7 and 3. Well, if I add them together, that gives me 22. The bottom gives me 10. My b is 10, so my factors are going to be 7 and 3. Now, from here, we need to make sure that this GCF stays with our problem. So I'm still going to keep a squared, but now 10a is going to be 7a plus 3a, and my c still stays the same. Now, we're still going to factor by grouping, but again, I'm still bringing down that 3. In this case, I'm going to pull out an a from the first set, and you get a plus 7. The second set, I'm going to pull out a 3, which gives me a plus 7. What's left in parentheses is still the same. Again, still bringing down that GCF. We have a plus 7, and what's left is an a plus 3. All three of these terms are considered factors to the original equation, 3a squared plus 3a plus 63. So make sure if you factor out a GCF, it needs to come down throughout your problem. It needs to be there. If we just do a plus 7 and a plus 3, you're going to get a squared plus 10a plus 21. Well, that's not my original equation. It's 3 times all of that. If I look, I can't factor out a GCF, so we're going to say a squared, ax squared plus bx plus c. Well, a is 10, b is negative 19, and c is negative 15. Well, if I look, a times c tells me I'm doing 10 times 15, which is 150. Now, here's the big thing with the negative. This means when you multiply, one factor is negative. Now, here's the thing to keep in mind. Now I'm going to scroll down just so we have enough room. Because b is negative, your bigger factor is negative. Your bigger factor is negative. Now, the only other thing we have to keep in mind for these, because one factor is negative, now we need to subtract. So if a times c equals a negative, you subtract. And I know it's a lot to take in, that's why we're going through these examples. So we have 150. Well, I have 150 and 1. I have 75 and 2. I have 50 and 3, 30 and 5, 25 and 6, and 15 and 10. Well, if I subtract all of these, because 1 does have to be bigger, I get 149, 77, 47, 25, 19, and 5. I'm still focusing on my b, so that means my factors are going to be 25 and 6. Now again, b is negative, so my larger factor needs to be negative. So I'm going to break this down to negative 25w plus 6w. Still bringing A and C down as they are. Now we're going to factor by grouping. I'm going to factor out a 5W from the first set, and I'm left with 2W minus 5. And I'm going to factor out a 3, and I'm left with 2W minus 5. Well, since those two terms are the same, I have 2W minus 5, and I have 5W plus 3. Please keep in mind when you go to do these, if B is negative, your larger factor has to be negative. Anytime A times C is negative, you subtract. Anytime A times C is positive, you add. If we look at example 5, we can't factor out a GCF, so my A is 4, B is 15, and C is negative 4. Again, A times C is negative, so we need to subtract. But in this case, B is positive, so your larger factor is positive. Well, AC gives me negative 16, so I'm going to say 16, 1, 8, 2, and 4 and 4. Well, if I subtract, I get 15, 6, and 0. If I look at my B, my factors now tell me it's 16 and 1. So I'm going to break 15 into positive 16B minus 1B. I'm going to bring A and C down as it is. Keep in mind, B is positive, so my larger factor has to be positive, making 16 positive. We're going to group them together. Now here I'm going to pull out a 4B, and I'm left with B plus 4. In the second set of parentheses, if you notice, we have B plus 4 in our first set, so we're going to actually pull out a negative 1. This is going to make B plus 4s inside my parentheses match each other. So we have B plus 4, and we have 4B minus 1. Now, unfortunately, we don't have time to do the sixth example to go over it. Please try it on your own. Please bring it to class tomorrow with any questions that you have. We'll go over it first thing tomorrow. We'll talk about when B is positive, when B is negative, whether to add or subtract, but I do want you to give it a try. Please bring your notes, any questions you have, to class tomorrow, and I look forward to seeing you then.